Thank you. So this is just very basic, okay, nothing too deep. So if you know how to spell AI or you don't know, this is the right course for you, okay? So before I start, I need to know what's AI. So can someone tell me what's your perspective, what's AI? That's the very first thing you need to know. You need to understand what is this thing called AI. Anyone want to volunteer? You know I can point, right? No, I'm just kidding. What's AI?
Ability for computers to perform tasks or mimic behavior.
Oh, okay, good. I don't have a definition, that's why I'm asking. Right, what about here? Anyone? Another definition?
Sentience.
Sentient, oh, okay. Do we have such AI, the sentient right now? Oh, I don't know. Okay, so now, first of all, you need to understand what AI, right? Define it, okay? Right now, there's a lot of definition, whether does it include hardware, does it include software, does it include environment? So that's one of the challenges I found right now. A lot of expert committee, all trying to figure it out. So once you've tried to figure out what this AI is, then you need to scope it, right? So what's the boundary of this AI, like this thing called AI, like what's the scope? You can pick whatever you want. You know, you can pick the one that we know right now. What's that thing called? OpenAI, chat something? Like, what's the scope of that? Like, how do you scope this, the boundary? Like, how do you scope AI? Well, if there's no boundary, how are you going to secure it? I mean, like, it's open system. Yes.
In the end, it's just software and hardware and feed the data, right? So that's like
Software, hardware, data. Okay. All right, so I want to start with basic, right? So my brain is very simple. I cannot take anything too complicated. So AI, so let's start with that. First of all, like, I'm going to go with very basic security stuff, right? Nothing too complicated. Those of you who are new to security, hopefully this will be fun. Okay, he looks like you look very intelligent. Do you mind just standing up here for a second? No? How about someone who's playing with the phone? Do you mind standing up here for a second?
Sure.
Yeah, see? Oh, okay, give him a big hand. What's your name? Huh? What? Sam, okay. Okay, let's imagine. So this is natural intelligence, right? You guys agree?
Yeah.
He's natural, right? I mean, you cannot be any more natural than that. He's sentient, right? So this is the extreme. This is what we call AI, right? No, not AI, natural intelligence. And let's say this is the AI, artificial. Right now, let's say it's just on my computer, right? So basic. So when you work for a company, when they say, what's your greatest asset in a company? What is it? People. Is this the thing or this guy here, right? Yeah. So he's the most because he has an eye, natural intelligence. That's really good, right? So that's the very basic stuff you need to know, right? Like all security, the first thing you know is what's the asset you're trying to protect, right? So normally this intelligence is much more valuable than this intelligence, correct? Okay, then the next thing in security, you want to find what's the value of this intelligence, right? Okay, you guys agree he's more valuable than this thing here? Yep. That's debatable, right? So, well, we'll talk about characteristic afterward, okay? So depending on what your need is, then you can decide what's the AI, so, or what's the AI is. So here, let's say I assume this is here, right here, on this PC. Every time I give a presentation on AI, the first thing they say, this AI is going to kill humans, it's going to blow up the planet Earth. Do you think this is going to do that? Are you sure? Yeah, all I need is just a little wire, or maybe connect to some nuclear bomb somewhere. Will it blow up the Earth? Possible, right? So you have to start with the very basic, find out the risk, find out your appetite, find out the value asset, and find out should you protect it, right? So that's the fundamental. Most people don't think about it. They just protect everything they can, or just get very afraid and so on, right? So let's say they have this AI here, and then they have an NI over there. So the next thing you need to do is find out exactly what these are. You need to define this AI here. If you define this as just a software, right, and you scope it just on this PC, it's not going to hurt you, right? Well, theoretically speaking, right? Theoretically speaking, it can hurt you. It can have flashing, it can hypnotize you, whatever. Let's not go there, okay? So let's say very basic stuff. It's not going to hurt you. It's just going to sit there. Although it can tell me how to build a nuclear bomb and destroy the Earth, but it's just going to stay there. So, and the next thing is that tell me, what's the difference between this intelligence and this intelligence here? What's the difference? Besides this much better looking intelligent than this machine here. What else? What other characteristics between these two intelligent? Or if you have to protect them, right? You guys protect people in your company. So what about this? Technically, if you classify this intelligent, I don't know what this intelligent means, right? So one of the things is that one of the debate has always been in the very basic, they talk about weak intelligence. You guys know what weak intelligence means? Anyone heard that definition? And strong intelligence? Oh, that basically just means that if this intelligence is at the level of a human being, right, of your brain, then that basically strong. So it can do the capability of a human and more. That means that it potentially will succeed this person. The intelligence only, right? Like this person can take a gun and go around shooting people, this will not, right? Although he had the same intelligence, he can even be smarter than him, but will not be able to do that. So you need to understand what you mean by intelligence, okay? And the other stuff too you need to know is, what else is differences between these two? Let's say in your company, after working, right? Do you go home after work, or you just stay in the office all day long, 24 hours, 365? Anyone work forever? No, but this one can work forever, right? Can he be fired and lay off?
Sure.
Can this be fired and lay off? No, it's going to stay in the company. Do you just take the piece of hardware, memory stick, or take this? And remember, 3D printed save button, right? And just throw it out? You don't, right? You keep it around. So some of this stuff here, when you talk about this AI stuff here, I'm not sure how many of you work in company that's AI.
Question.
Yeah, go ahead.
Can he be fired if he has his end of life?
Be fired?
Yeah.
End of life? You tell me, do you throw your software around, away? Like in a company, do you guys, when the software no longer in use, what do you guys do with the software? Replace it? What do you do with the other software? Eventually, you throw it away. How many programmers in here? What do you do with your old code? You archive them, right? Or it could be still existing in your branch somewhere, right? I don't know, GitHub, whatever, right? So you keep them around, right? So that's the other stuff. Talk about security. You have to know the asset. You have to know its availability. When he gets fired or laid off, or 5 o'clock he goes home, this intelligence done, right, for the day. This is going to be around, right? It may or may not be active. At least availability is still there, right? So when will it be instantiated? That means it come to life, maybe in the middle of the night. I'm not sure, right? So those are the kind of things you have to worry about, right? And you talk about intelligence. How many use AI? Like you use AI at work. When something goes wrong with AI, it gives you the wrong answer, what do? How many of you call your help desk? How many of you? No? So now you have to build AI into, so that knowledge you have to go to your help desk, right? Like you have to go into your first line of support, your second line of support, your guru, your ninja, right? Those in IT, you know what I'm talking about, right? So you have to know those kind of stuff, right, in terms of just managing AI. Now, AI, to me, there's 3 levels. One is the AI itself, the interface. This is what I'm covering right now. And then there's also security on the internal AI. That's more technical. And then the one that I know is coming, which is the environment of the AI, okay? For example, if you talk about sustainability, company all worry about that. Security has to be part of a business. When you talk about ESG, right, sustainability, like in terms of AI is very costly, right? It takes a lot of power, okay? So I won't go there, but if you have time, you can ask me a question, we can go there. And then the one inside, we're talking about the algorithm. If you look at the algorithm now, when you talk about AI, what's the architecture you think about AI right now? Well, those of language, what architecture, what kind of network architecture do you think? What were you saying just now?
Large language models.
Large language model. Okay, that's just a model, right? Architecture-wise, most of you probably thinking things like neural network. You guys heard of something like that, neural network? Yeah, so neural network is supposed to be simulating the human brain, right? Now, keep in mind, if you study, AI has been around like since the 60s, 70s, right? So we have 5 different classification architecture of artificial intelligence. Neural network is just one of them, right? I'm not going to go into detail, but if you look at the math part, just like security, the fundamental of information security is mathematics. So this is AI is nothing more than just math. If you break it down, the core of it is nothing more than one really long equation. Or you can have many different short equations, or you can have one very long equation, you process it many different parts, different times. Why am I mentioning that? Because it's only recently that, for the longest time, we processed one very long math. And later on, I think in the 70s, the Japanese guy, I forgot the name, start to break it down into many different subsystems. And depending on which part of the equation you use to produce it, it had different category and so on. So it has been around since the 70s. It's only today that what we have here compared to what he can do is that this is getting really, really cheap, okay, and really fast, doesn't take a break, and can last for a long, really fast, take a break, yeah, and doesn't complain, right? Doesn't take a break, for example, that he will do, right? And it's very, like, for him to be able to get to this level is very expensive, right? But energy consumption-wise, he's very cheap compared to this machine here, right? Okay, so all this ties into things like availability, ties into integrity, right? Now, human brain in such a way that the neurons and stuff, I'm not going to medical, but sometimes it does degrade. There are studies that say that it does grow, but the research has to be long enough for it to grow and so on. But this machine doesn't, right? Adding more memory doesn't constitute its growing, okay? And human is not perfect. You know there's a delay between the brain and the actual action, but this doesn't, right? There's no delay. So it's too perfect, okay? Now, even if you do AI, those of you who use things like generative AI, like ChatGPT, you'll notice that even if you try to tell it, pretend to be dumb, it's not really dumb. The smartness is still there, right? When a human is dumb, not him, right? Me, right? And I'm actually dumb, right? There's degradation. We do lose, though that actually has power. If you study AI or NI or CI, cognitive intelligence, natural intelligence, so you have to treat the human a little bit different than this, right? So when you get information out of this, so when you can tell it to pretend to be something, but its integrity is still the same, right? So integrity in terms of the intelligence is still the same, but it can pretend the persona and the outcome perception that you look at it is different. So now that will impact the integrity of the intelligence that you're gonna see from here, right? So confidentiality-wise, and also this integrity-wise, the integrity of it, if you use the one in the cloud, you'll be shared with everyone else, right? But when you get a subset here, let's say the whole AI, or the model here, it'll be a subset. Can you make it the scope-wise the same as the one in the cloud? Yes, you can, but you may lose degradation in terms of quality. But that is constant, right, in the sense that over time it doesn't. It may be obsolete, so you may have a degradation in intelligence in terms of no longer usefulness. But in a human case, the degradation may be there. As we get older, we forget stuff, but we can relearn, right? So this doesn't. So from that perspective, to access this and so on, maybe some confidentiality too. You need to know what you're going to get out of it, what you're going to put it in. And because it's not as smart, you guys heard the case about the lawyer who went to court and say that, well, he's trying to do a research and tell ChatGPT, say, give me 3 cases that's similar to this case that I'm going to court for. And then ChatGPT say, here you go, give me the references, here you go. He went to the judge. The judge was very impressed that he got all these cases with references. Then they found out, the judge said, for some reason, after all these years, I never heard of these 3 cases. Look at the references, doesn't exist. So ChatGPT really good at making things up, right? So he got fired. So yeah, so you have to check, okay? So it's very important, even you look at AI, right? You have to check. That's why lawyer always say, now we need to cite this thing. You guys are all professional, correct? So for your own integrity, you have to make sure you have citation, right? He will tell you where his sources come from. Another thing that's very different is that there are law regulation. Anything he can remember, right, he can reproduce it without so-called, depending on how he reproduce it, he doesn't have to provide citation, integrity of the information. But this is very hard, right? Because you come up with knowledge, it's very hard to guarantee that it's the truth. Okay, for the last few months, I've been monitoring, places that try to cheat, get this thing and submit it into as their own work, right? And then people who try to have create more AI to try to detect the AI, and then the AI trying to build more AI stuff that trying to bypass AI and so on. Keep going back and forth. I think that's going to be going forever. Okay. So if you look at any citation, right? Any citation, you notice that they actually show. How many of you do citation whenever you use AI? Come on, I'm going to see all hands go up, right? You are all professional, right? So you should. I mean, like, all the citation basically just says, I did use AI on this year over here. Most of them don't even know there's a version number, right? So just to let you know, so you need to provide proper citation for this. So they are hybrid model right now. I think places like IBM and so on are working on it, where they can try to reverse the AI and provide citation. Now you're going to have integrity. Okay. I don't know many places. I know IBM started to do it. So now they're going to have more non-repudiation, right? That's also a very important thing in security, where you're trying to find out the output that you get. You can actually trace it back to the source, and you cannot dispute it in terms of what you get and what the source is coming from. Okay? So as you see, in AI, it's not that difficult in order to apply security to it. Okay? In terms of all the CIA stuff, non-repudiation, and so on. Now, the very important part too, let's talk about privacy. Okay? So he, a human, he's really tough. Doesn't he look tough? Right? If I want to get some really personal stuff out of him, I probably had to beat him up. More like he beat me up first before I can get it to him, right? So see, he smiled. He knows that he can beat me up. So anyway, so it's very difficult, right? For this computer, it's very gullible, okay? AI. So far, I haven't found an AI where I cannot. You try. Don't do this at home, okay? So in case you get in trouble, I say how to build a bomb, right? But obviously, when I teach, I don't say build a bomb. I say, how do you cheat on the test? They always say, no, cannot. That's not a good thing to do. Or I try at home, how to build a bomb. They say, you cannot do that. You only take another line of code, type in another sentence. The next thing you know, it tells you exactly how to build a bomb from scratch, right? It's not really smart, right? Another thing, too, is that, and this question I like to ask when I go to those heritage, when I present to people who speak in different languages. What's the mother tongue of ChatGPT? It's a large language model. What language does it speak? What's the mother tongue of this AI? Do you have a mother tongue? Or what do you speak? What's your main languages? What is, huh?
Yoruba.
Yoruba, okay. You guys all have a specific language you're born with? What's this mother tongue for this language here? For this AI? I don't care. Any AI you pick. What's the large language model? Come on, this is a trick question. Huh?
Bits and bytes.
What?
Bits and bytes.
Bits and bytes? Okay. What thing of, huh? English? Yeah, that's what a lot of people, when I present it to heritage schools, right? They say, yeah, they say whatever language. Then I show them, I can mix all the languages, right? I can put it in Chinese and say, Chinese, please develop a poem in haiku, and I put it in Nippon, Japanese, and I can put 5 different languages. You're still able to produce an answer in my choice, right? Then I say, present it in, I didn't quite say Urdu, but I think Spanish or whatever, and French and German, and you'll produce stuff for me. So if you go study how large language model and how this all been trained, it's nothing more than compiler. How does a compiler compile program? Any language, right? Computer can understand any languages, right? C, C++, A, B, C, F, I don't know, F#, whatever. So same thing, if you look at how they study it, it's the same thing. They use tokenization, they use symbol tables and stuff. So fundamental computing stuff. Ask some computer people, they'll tell you that. And so same thing. So they don't really know languages, right? They go by pattern, right? So the keyword for this particular one will be the ChatGPT generative will be something called what's the keyword? What's the breakthrough in generative AI? What's the one word that, huh? Predictive? Natural language. So the keyword is called attention, okay? But the breakthrough that makes it be able to distinguish all the nuances in different languages is called self-attention, okay? Go download the piece of paper, and halfway through the paper, and it tell you, like for example, it's a self-attention, it gives you the AI capability that say what happened when, you know, when I say hollow legs, what does that mean? What does, anyone know what, when I say you have a hollow leg, what does that mean? Huh? Yeah, I'm always hungry, yeah, because my leg is hollow, right? But that doesn't mean I actually have a hole in my leg, right? So that's is the capability. So you have to know fundamental what it is. So it's the algorithm, it's the math. I'm not going into detail. You can go read the paper yourself. That's what makes this AI very different. Human just naturally, they know. I'm still trying to figure out after all these years, after studying human brain for over 10 years, I'm still trying to figure out how a human works, right? I have kids. I'm trying to find the point where they start to like even roll over. I cannot figure that one out. Just magically overnight, you know, all of a sudden, what happened, right? So all of a sudden they stand up, all of a sudden they start walking. I still cannot figure that one out. I did not quite experiment on my kids, you know, I just observe, okay? So no child abuse there, no child was hurt during this experimentation. Good to know, yeah. So I want to let you know, so that's the AI part of it. So we cover a little bit of C, the I, the A, the non-repudiation. If you want more example, I can go into more detail. Privacy, very similar, right? He can keep his mouth shut. This one, I can bypass this quite easily. You just go experiment. It's not too bad. So once you understand how it works, actually my source on exactly how this works, I think I watched a video from a professor at MIT. So he break it down in just one very long equation, and depend how you use the equations. And basically, that's all it is, right? So, so the next thing I want to talk about safety, right? So this day, a lot of this has to do with safety. So safety can be at those three different levels. You can do the safety in the math part. So when we have, when it have, you know, a whole bunch of experts who do programming, so sometimes I have to go analyze the code, the algorithm, that's a little bit more technical. But for example, let's say you apply this to things like industrial stuff, health, right, where human life is attached to this system, and it could die. So a couple of things. I'm not going to go into detail again. A couple of places you can put the safety on. You can put the safety as it generates the message, right? What if you know internal, you can prevent it from creating the so-called safety, potential safety hazardous message, signal coming out of it, or the interface, or directly at the object that you apply to, right? That's very fundamental security that you learn where you can attack through something or at the object itself, right? So that's a very basic security fundamentals. See, you don't need to go to advanced security stuff. You can apply your foundation, your fundamentals to what you're doing here, right? So the same thing when you guys do industrial. How many of you in industrial, like oil and gas, water, traffic, health? So same thing, right? So you have a whole bunch of safety, you have a whole bunch of feedback loop, right? So you can either have a signal along the way. Now, the only difference is that the security side and the safety side may interchange depending on the time critical sensitivity. The only time I found safety comes first before security is when humans cannot react fast enough, especially even physics find it very difficult to be able to detect and prevent, control the security. That's when safety will come first. But most time they let control goes first, then safety will come in and rescue if the control went out of control. Okay? So keep that in mind, all right? So an example will be things like if you work in utilities. Who works in utilities? Transmission, right? We talk about things in like millisecond, right? Or even less than that. So when you look at those systems, they don't even let you do anything. Even the US government makes sure that you can only change parameter. You cannot even touch the algorithm because they want to make sure that the algorithm, now I'm going to the internal now. For example, when you're math, you guys do math, some of you probably do some math, but sometimes the math can be stable or not stable, right? And then you want to make sure that whether it's go out of bound, not out of bound, in terms of whether it's in control or out of control, right? So that's where the math come in. To know the math a bit, then you can control it before the intelligence actually manifests itself onto the surface where human can see it, right? So that's more system engineering, system security level, where you need to be able to control before the root cause of the malicious action, signal or whatever, start propagating. The propagation is called errors, all the way to the surface where you actually manifest and be able to see the failure, right? So that's just very basic system security. So that's one of those things you got to understand where you're going to apply this AI, all right? So, so even if you don't know the math, you can just control at the interface. And it's common, right? Most people use control system, whether you use SCADA, DCS, IED, whatever else, you will know that we don't need to know the controls. We don't need to know the proportional integration, derivative algorithm that they implement in it. But you can control external, okay? So, so you just ask whoever created to know. Now, for example, he learned another very important thing, characteristic is that he has some level of education, right? Just go, yes, yeah, okay, he thinks so. He forgot already. See, this natural intelligence. Now, the thing is that he knows when he doesn't know something, right? The problem with this, he only knows when he trained not to know, okay? If not, it can give you garbage out, right? That's another issue with AI is that it doesn't know. So how many of you actually, in your company, you actually went and get AI? You ask your AI department or machine learning department, say, give me a model, and they give you a model, right? And then you run it. Now, it's based on certain data that it doesn't have any other internal, any more additional input until it got retrained, right? But in his case, he doesn't. He has professional development. He comes to BSides. This AI only comes to BSide and sleep. Here, my screen is black, so he's sleeping now, right? While I'm trying to use it. So he doesn't, right? So this model can go out of date. Be very careful. So one of the things, if your company, whenever anyone gives you a model, they always say, okay, you want to know the limit. How long, what's the lifespan of this? At what stage you start trigger, that means that you can no longer use this model. It's obsolete. You have to be retrained, give you another enhanced model. Obviously, he's the greatest asset in my company. We cannot fire him. We send him for BSide for professional development, correct? Yeah, see? Or he can go for training, right? So that's different. In this case here, it doesn't. So you have to know what to do with it, right? Now, because if I can trust him, assuming he's not an internal threat actor, or when he leaves, he retired, that's fine. But this software is my intellectual property, right? I cannot keep him. He's also my highly valued intelligent asset. But this I can keep because it's my software, right? So if this is dangerous, especially as you saw the keynote speaker, so if this particular object or API or software or application or AI has credential in it, it might be there for a while, right? Okay, what does that mean? That means that it's going to be in your company, so it can actually, a bad actor who knows that you have this agent in-house can actually activate it, turn it on, and let it run through the system and make it do really, really bad things, right? So those are some of the stuff you have to be careful. You have to kind of treat this AI almost like a human asset and also treat it as it has special characteristic specification that you have to treat it, okay? So for my work, either in the military intelligence or in the industrial intelligence, all I can tell you is that you can actually manage intelligence system with knowing very, very little about it. So don't have to worry about thinking that you have to be really smart or know a lot of stuff to secure the system. You don't really need to do that, okay? So don't panic in terms of, oh, geez, I don't know, this is a new stuff. It's nothing more than just basic math. Well, a little bit more complicated, but who cares? We all survive up to this day without knowing math, right? Well, at least I survived all this without needing to know math, right? But you just need to know how to secure this. That's one of the things that we always debate. when I go on those expert committees, that do you need to know math or do you need to be a programmer in order to be able to manage that? So the answer is depending on what you do, right? There's a lot of people who say, Vincent, I love security, but I don't want to be like technical expert. I say, look, there's governance. You can do that, right? Become a politician, right? So there's different level. So don't be afraid. So there's a lot of entries into AI security. I think there's 2 more presentations today. Go listen to them. They're probably going to add a lot of values to what you do. So yeah, that's just the basic stuff. I want to rest assure people that don't be panicked. The only thing I found, even Canadian cybersecurity, the Canada level, I talked to them, they basically told me that we just need people to study a bit more, learn a little bit more of it. Don't be afraid of it, and we need more people in this area. So yeah, I'm just going to stop there. Anyone have any questions? Hopefully not too in-depth, not too technical. Or if you have technical stuff, you can ask, and I'll see whether I can try to answer it. Yeah, thank you very much, yeah. So, yeah, okay, sure. Get it from him. So yeah, so a lot of this stuff, so this applies to all the things, whether you apply to like JetGPT, Transformer, or you can apply to those like Midjourney, Stable Diffusion, or whatever. Fundamentally, the math, the algorithm is very similar. The quality, the validation, the test method is all very similar. Security-wise, you can still apply. But if you know the math, then it's a lot easier. You can tell where the solution is, where does it go, where does it get distributed, the quality of it, then you can throw that. So that you can have much better control. Like security, we all are very concerned about the control of AI, right? So anyone have any questions? Yes.
Okay, I think I'm loud enough. You covered security from the traditional points. How about security as in data that is being fed to the model?
Oh, yeah. So that's the other part I forgot to mention is the input, right? So if the garbage in, garbage out, right? So the whole concept of maturity model still comes into play, okay? Like when the military asks SEI, Software Engineering Institute, to increase that still can be applied, okay? So you want to make sure that the quality of the data that comes in, the integrity, and also the confidentiality, because you do not want the data that has not been having approval to come into the data as part of the learning process. So I'm still waiting for the court to decide how we're going to handle that, right? Right now, people are suing OpenAI right now. Let's see how the court play out. Like, for example, cryptocurrency, there's already rules, precedent has been set in Europe that says that if you have money laundering, when I used to track terrorist funding and stuff like that for financial, so we have to draw a point somewhere that say that when this bad money, laundered money go into certain crypto, into the blockchain, and depending on the amount that went in, the same amount that come out, that at this point, this became fraud, right? Fraud cryptocurrency. So AI, we're probably going to see the same thing, similar things. So we're in discussion to see how we're going to decide when data that's bad going in and how it's been processed. I just use the generic term process into it, okay? So any other questions? Yes?
So, we're sitting in Edmonton, we have the world's leading authority on reinforcement learning.
Yeah?
Dr. Richard Sutton. You guys are linked between the University of Calgary and the UA in those areas?
No, actually, I was on the Standard Council of Canada. We went and go to all the committee of all the AI around the world. You know where the top AI research in the world right now? Montreal. Yeah, so I'm not kidding you. Yeah. I'm not saying other universities are not good. I know U of A actually have a really good school. Yeah.
There's the University of Toronto in Montreal and the U of A.
Yeah.
Three leading AI facilities. The U of A is number 3 in the world.
Could be, yeah.
Yeah. So Montreal is not necessarily, it's very good, and so is the University of Toronto. But
Yeah.
the UA here is
Okay. Yeah, the information I got is from United Nations. When we have 150 countries, we meet together and we discuss who are the best in the world. That's what they say. And it's not my answer. Okay, I just let you know that's what the committee, planetary committee said at that time. So.
Is there any research being done on AI, using AI for security purposes
Yeah, I think like over 10 years ago, I do that in industrial. I do that in the military. Yeah, they do. I'm not sure about here. I think they do too. Some of the vendors, I don't think they are here right now, but there are people who are doing that, yeah. So it doesn't have to be clean signal. Sometimes clean signal is a bad signal because the real world is very noisy, but when you get a really clean signal, means maybe someone tapped into it, and that's why your signal get really clean. So sometimes you have to do the opposite. So yeah, they do have a lot of research. Yeah. Okay, thank you, everyone.
Thank you very much.